to go outside. Love you. Okay, so it has finished doing our training. Let's take a look at the random forest. So as I mentioned, it was a bunch of models. So this is the same look as a decision tree, but you can see we've got a whole bunch of them, and each one looks different. Right? Each one is broken up differently. They're all smaller than that one we saw that was just the decision tree, and there are 140 of them. Right? So the way that works is the algorithm takes the data, it runs each observation through 140 different tests, and then it takes the results of those tests and basically does the average, whichever classification has the most entries wins, so either 1 or 0. And the last option was called gradient boosted trees, and that's very similar. Let's take a look at it. See, it's the same, but with this, all of the lines are the same width, right? Everything is equal, and that's just the function of the technique called boosting. Boosting is just a way of inflating or adding to some of these numbers, combining them in certain ways mathematically. So there's going to be 150 different models here. But because they're boosted, everything's consistent with each one. And let's see how it looks on the results. On the results, the gradient boosted trees actually has the lowest error rate. It did take quite a long time to train, but it was actually faster than the random forest. Right? So we now have a new model that is correctly classifying things with only an error rate of 2.5% plus or minus 0.6 percentage points. So when we started, we used the naive Bayes classifier. We were off by 10%, and our last model was only off by 2.5%. So it's a substantial increase, right? That's a reduction in error rate of about 8 percentage points, 7 percentage points. So really big improvement. What we have already shown here for us is our confidence interval with the little eye looking thing. All of this was done automatically without us having to do any work. So we now have a model that is here. We can come down to the very bottom and we can look now at our correlations. This is a correlations matrix. We can see that the darker the color, the stronger the correlation. There's a strong correlation between age and experience. That makes sense. There's a strong correlation between average monthly credit card spend and income. That makes sense. Let's see what this one is. That's whether or not you got a personal loan is negatively correlated with how much you spend. So all of that done for us. We can save these results. Save it here as Dana 3367. And we're done. So we were able to do classification with a big data set, all visually without having to use any kind of numbers or click on things like we do in Excel, all done for us. Right? Oh, that's the rock curve. We can see that our gradient boosted trees actually performs the best up here. And finally, we have this option for deploying, which means that we can create an endpoint where we would kind of save this. So if we set this up with a website, we could basically imagine emailing your data set to the website. The data set would do the work and then send you back the results. What this would do is set up, it's called an endpoint for an API. You would put your data into it and it would give you the results set back. Since we don't have a website, we'll stop here. But that is a way that when you're ready to, you wouldn't ever have to come back into RapidMiner. You could just save that, and then anytime you needed to do a decision tree with this data set, you could say, hey, this is the person data I have. Here are the variables for that person. Computer, what do you think? And it would give you the prediction all directly for you. So that is doing classification in RapidMiner.